Good morning to one and all. Today we will revise the previous class for 5 to 10 minutes, and then next we will go for the today's topic, that is MOSFET, metal oxide semiconductor field effect transistor. So last class we discussed about the BJT, that is bipolar junction transistor. Here that means P-type or N-type semiconductor, either P-type or N-type semiconductor is sandwiched with the opposite pair. That means, for example, N is there means it is a sandwich to the opposite P-type on both sides. That is a PNP. For example, N, for example, P, it is sandwiched to the opposite. That means NPN transistor we can get. Means PNP and NPN transistor. This transistor is mainly used to control the current or to regulate the current. Most of all the transistors like that only. And then next, in the NPN transistor we discussed it, and PNP transistor also we discussed. That is a bipolar junction transistor. This bipolar junction transistor. In the NPN transistor, the majority carriers are electrons. In the PNP transistor, the majority carriers are holes. In that, again, I'm remembering to you, while drawing the circuit diagram, you have to draw correctly that the terminals, it is a plus minus, you have to give correct circuit diagram, otherwise total completely the drawing will be wrong. So be careful in drawing of circuit diagrams. I think all of you know that already you studied BEE, right? You faced so many problems. So again, I'm remembering to you, while drawing this circuit diagrams, we have to mention clearly plus minus. In that plus minus, even though if it is total drawings is correct, plus minus is wrong means then total thing is wrong. So maybe the explanation also differs. So be careful in that. Nagaraj, he asked to circuit diagram once. Already last class we discussed about NPN and PNP transistor, right? You best go for a video for that. I already posted. Hmm? Nagaraj, okay. And then next here in this metal oxide semiconductor, I will show the circuit diagram for this, right? Plus minus. So Nagaraj, I will show you the last at the end of the class circuit diagram, NPN and PNP. Then today we will discuss about metal oxide semiconductor field effect transistor. This field effect transistor in the syllabus, it is diode. In the syllabus, it is a solid electronic, solid state electronic device. The first topic is PN junction diode. The next topic is BJT. Next is FET. In the FET, now we are discussing about MOSFET. MOSFET is also nothing but field effect transistor. FET means it is a field effect transistor. It is field effect. Here, this is a field effect transistor. Field effect transistor. It is a term that controls the current. That controls the current through a circuit by applying a voltage. That is a variable voltage. It behaves like a voltage controlled resistor. That means this transistor, field effect transistor, nothing but it controls the voltage. In other words, I already told you that it is called a resistor. In the transistor, in the name itself only, transfer plus resistor. So transfer plus resistance, that means it transfers the resistance, right? Means here, in other words, we can also call it as a resistors. So here it is mentioned here, voltage controlled resistor. Transistor is a, it controls the voltage, or it controls the current. Here it controls the current through a circuit via an applied voltage. That means when you apply the voltage, automatically the current will control. So, and it behaves like an voltage controlled resistor. And then here in this FET, two types are there. One is uh, no, there is normal, that is a junction transistor. Another one is a field MOSFET. So MOSFET means metal oxide semiconductor field effect transistor. In this FET, three terminals are there. That is a gate, source, and drain. These are the three. In the previous, what we discussed in BJT, three terminals are there. Transistor, three terminals. In the previous, what we discussed in BJT, in the transistor, the BJT, that is bipolar junction transistor, three terminals are there. The names of the terminals are emitter, base, collector. But here, gate, source, and drain. Gate, source, and drain. Here, a source is nothing but the source of the electrons, and drain is the destination of the electrons. But there is in the comparing with the BJT. In the BJT, the source is the emitter. That BJT source is the emitter. In the emitter, electrons are emitted. But here it is source in this MOSFET or FET. Drain. Drain is the destination of the electron. Means whereas in the transistor, the destination is the collector. The emitter, collector. From the emitter emits the electrons, and then the collector, it receives the electrons. And in between the emitter and collector, one is there. What is that? It is base. But here instead of base, it is a gate. Here that gate, here in this FET, this gate is the common terminal for both input and output. So remember this point. Here there is also the common terminal for both emitter and collector, the bases. But here it is also gate. The name is gate. The gate is the common terminal for both input and output. This one, the difference we have to understand. So again, I'm repeating the difference. The BJT and this MOSFET or FET, field effect transistor. Simply this, see here in this, again I'm reading. In the previous, that is BJT, three terminals are there. One is emitter, second one is base, and that is disconnected automatically. So, sorry for inconvenience. Now it is audible to you. Anyone can respond. It is audible. It is audible. Hello, number 301. It is audible. Anyone can respond. It is audible. Number 301, 301, 380, anyone can respond. 366. It is clear? Number 77 is audible, right? Right, right. Okay, okay. Now we'll. The next here, the just I will tell the difference. Here, some due to some network issues, automatically the net is disconnecting. Here, 2 times it is disconnected. The next, I will tell you the difference between clearly. All of you listen carefully. BZT and FET. So 1 minute, 1 minute. Okay, I make all the things. Like, so now it is it's kind of some loose connection, so that's why uh, it is disconnecting and it is connected. Okay, right? Now it's clear. Uh, the difference between BJT and FET. The BJT emitter, base, and collector, three terminals. But here in this gate, source, and drain. There in the emitter, the electrons will flow from the emitter. Here from source, the electrons, the source of the electrons. From here, the electrons. And in the collector receives the electrons or holes depending upon the major carriers. audible? Is it audible? Number 30, video and voice. Now it is correct. Suresh, it is audible or not? Any one of you can respond. 310. Number 33. Yes, yes, absolute right. Some net issues are there on my side. So I request to all of you better you stay here just 2 minutes. I will restart again. I will again join. Request you please stay. Now it is clear. It is audible. Now anybody can message. Now it is audible to you. Okay, right, right. Now we will continue the class. So now in the previous, just we will discuss 2 minutes the difference between BJT and now it is correct. Low voice. Now it is voice is correct. Number 43 lateral entry. 43 is audible. It is audible to all of you. Okay. The BZT in BZT emitter, base and collector. Here in this case, gate, source and drain. The emitter, it emits, that means electrons, it is the source of electrons in the emitter. And here the source of electrons is the source of electrons is that is the source is the source of electrons. And drain, here in this case a drain, the destination of the electrons, whereas in that collector is there, it receives the electrons. That means that here the source current is there, drain current is there. There in that case emitter current and collector current is there. But here in the gate it is a common terminal to both input and output. Whereas in that base is the common terminal for both emitter and collector. So same similarly here. And then next we will go for the next slide. MOSFET. That is a metal oxide semiconductor field effect transistor. In this, if you see uh, clearly, this metal oxide, metal oxide, this metal oxide. So metal oxide is a semiconductor. That means, in other words, it acts as a dielectric, partial conduction. Metal oxide. This metal oxide here in the MOSFET, it is a silicon dioxide. We are using silicon dioxide in this MOSFET. A metal oxide is the name is a silicon dioxide, SiO2, and it is a semiconductor. S is a semiconductor, and it is a field effect transistor. It is a transistor. The MOSFET is metal oxide semiconductor field effect transistor. It is a MOSFET is a FET with an insulated gate. The gate is insulated. The gate here, the gate is insulated means the gate is insulated means, 1 minute. The insulated, that means dielectric. That is dielectric is nothing but metal oxide. That is silicon dioxide. Silicon dioxide insulated. So today's almost all most transistors are digital integrated circuits. Digital integrated circuits. The MOSFET source, gate, and drain terminals, same like the FET. The gate lead is not connected with the body of the device. That is not connected with the device. Is not in contact. I will tell you next description. This MOSFET is higher input impedance. Here, impedance, what is the meaning of impedance here? Resistance. The higher input resistance here than that junction JFET, that is a junction field effect transistor, we will discuss later. And MOSFET even less of a load on preceding circuits. Correct. So the next here we will discuss about the MOSFET now clearly. This is the symbol of MOSFET. Here in this is a three terminals: gate, drain, and source. And this is the substrate. This is the substrate here. And then here this is if you see here in this is the MOSFET construction. In the MOSFET constructions, the one side is a P substrate. P substrate. That is only one region. That is a P substrate here. P substrate. And then here this is the other side is this is a N type region, and this is a N type semiconductor region on the drain side, and the source side is also N type region. That means this side is completely P type, and this side is completely N type. That is the source N type semiconductor is on source, and N type semiconductor is on the drain. And then here this is, if you consider, this is one plate. This is a plate, and if you consider this is another plate, this is another plate. In between the two plates, here the oxide layer is deposited. Here the oxide layer, that is a silicon dioxide, SiO2, SiO2, SiO2 is deposited on N channel, is deposited on this N channel, and this gate is deposited on the oxide layer, silicon dioxide. This is the gate. Here the gate, this is a gate, this gate is deposited on the another that is on the oxide layer. So that means what you have to understand here, anybody can tell you this about this. Here, if you consider this is one plate, again I am drawing clearly, all of you clear observe. This is one plate, right? Right? And this is the another plate. In between these two plates and oxide layer, that is silicon dioxide insulator is there. And then this gate is mounted on the oxide layer, and this oxide layer is deposited on the one plate of the N channel. So can you tell what is anybody? Anybody, just you have to post to message in the chat box. Again, I'm repeating here, MOSFET construction. Here it is a P substrate here, the one side of the construction, a P side substrate, and here a N type semiconductor. That is, if you consider this channel, N channel, and if you consider this is a P channel, right? Then this N type semiconductor on the side of the drain, and this N type semiconductor on the source. And here the oxide layer, this oxide layer, this is oxide layer. See here, this is the oxide layer. This is the oxide layer is deposited on the N channel plate, and then the gate, this plate is mounted on the oxide layer, silicon dioxide. So now these are the two plates. These are the two plates. In between oxide layer is there. That is silicon dioxide. Can you tell what is this? Anybody? Anybody? Anybody know or not? Then I will continue. Don't waste my time. Now it acts like in which way? One device is there. Number 16, 36, 36, regular, fast. Whether you know or not, don't waste the time. I will continue. Okay, 36, tell. So now what is this? Sir, if you are online, better concentrate whatever I said in the class. Number 36, please tell. What is that? Anybody? It acts like a device. Anybody? No or yes? If yes means post that name. Fast. Fast. Not tell no. So nobody is responding. 304. Regular 304. Whether you know or not. 304. 308. And 309. 304 lay demo. He is not there. 309 is also he is not there. And Kiran 321. 321 Kiran. No. Okay, right. Anybody? Here this one acts as a like a, what is this? Anybody, can you see? I am telling these are the two plates in between dielectric, and that means insulator. What is this? Anybody now? 321 lateral is saying that resistor. So now here I am saying this is one plate, right? One plate. That means the oxide layer is mounted, is deposited on that plate, that is N channel plate, and then again on the oxide layer the gate plate is there. So this is like, this is one plate, and here it is actually one plate, and this is one plate. So here what is this? Anybody? What is this? What is this? Right, correct. You absolute right. 304 to separate the charges clearly. Can you name what is the symbol of that? I'm asking the symbol. What is this device? Now 304, you are coming correct to separate the charges. Absolute right. So name it. What is that? Already you've seen so many times that symbol. Absolute right. Capacitor 363, correct. 308, correct. It is a capacitor, right? It acts like a capacitor. So now this MOSFET at here, it acts like a capacitor. And one person said that to separate the charges. Yes, correct. That means if you see, for example, in the capacitor, one side if it is a plus means the other side is minus. If one side, example, the one side is minus means the other side is plus. To separate the charges, to separate the charges, right? Correct. This acts like a capacitor. Remember this point. In MOSFET, here this is, if you consider, this is a N channel plate, and on N channel plate, oxide layer, that is a silicon dioxide, is acts as an insulator, that is a dielectric constant which is deposited on the N channel plate, and thereby the gate is mounted on that oxide layer. The gate is mounted on. This is a gate is one plate, and N channel is another plate. In between these two, dielectric is there, that is the silicon dioxide. So now it acts as a capacitor. It acts as a capacitor. It is two plates. In between, dielectric, silicon dioxide is there. Oxide, metal oxide layer is there. So it acts as a capacitor. Now you got the clear idea, right? Then next, come to the, in this MOSFET, two modes are there. One is the depletion mode, another one is enhancement. Now we will discuss depletion mode in MOSFET. So now see here. So whatever the principle here, now we discuss the same principle here also adapted. Same principle. To separate the capacity works like a capacitor. So now in this is a depletion mode. This is a depletion mode. All of us just 5 minutes discussion. You can get the clear idea. So here VGS, this is number 80 asked the circuit diagram. So right, so here in this, see VGS, that is a gate to source voltage. Gate to source voltage. When you see here, this is a negative and this is a positive. This is a negative terminal if you give to the gate, right? So that means when you increase the negative gate to source voltage, negative gate, that means a negative terminal, gate to source voltage, this is negative. And the other side, it becomes, what is the other side? On the other side, it becomes compulsory positive, right? This is the positive charges. Other side, positive charge develops. Am I right? Clear? See here, this is one plate, gate, and this is the another plate. And in between, this is the metal oxide layer. And when you apply, this is a VGS, this is a variable. This indicates it is a variable. Changing. We are increasing the negative here. This is negative. Negative is connected to the gate. We increase the negative gate to source voltage. Thereby, this side is negative. The plate of one side, the gate plate is negative. The other side develops positive. This is a positive, right? If you increase this gate to source voltage, the variable, the regulator, if you increase the negative voltage, what happens? The other side of the plate, the positive charges increases. The positive charge increases more, and it depleted the here. This is N type. All of you know this is N type in the MOSFET construction. So we discussed it, and here the P type. P type substrate means again a positive charge only. The P type substrate, it is positive charge only. If you increase this negative gate to source voltage, here the output of this plate is positive charge increasing. So that means it depleted the here n-type semiconductor is there. Negative, that means electrons are there. If you increase the negative gate to source voltage, the positive charge increases. It depleted the electrons. It depleted the electron, the flow of electrons. That means the positive charge increases. Once the positive charge increases in the plate, thereby the current decreases. Yeah, thereby the drain current ID decreases. Thereby the drain current decreases. Or you got my point? Here the drain current decreases. See here, once at particular point, this drain current becomes zero. That means the zero means the positive charge is more. It depleted the electrons. Here the n-type is there. Here, if you see here, all of you see here, this is n-type is there. N-type negative charge is there. But here, if you increase the negative gate to source voltage, the other side positive charges developing is more. So this positive charge increases, it depleted the free electrons. So thereby the current, the drain current output decreases. And then at one particular point, it becomes maybe zero. Or of course, maybe zero. And then at VGS is in off condition. That means VGS is in off condition. That means the output voltage is zero. VGS. That means output voltage, gate to source voltage is zero. So now it is clear. So now number 80 asked that, right? Number 80. So here this what I said that in the circuit diagram, if in the depletion mode you have to negative gate to source voltage. That means negative terminal is connected to the gate, right? For example, if you here in the examination plus and minus means the total completely wrong, even though if you draw complete drawings. So you be careful in that while giving minus and plus. That is what I have said in the beginning of the class. Number 80, now you got the point. Number 80, you asked the question in the beginning. So what I am telling it to you in the while drawing in the circuit diagrams, this minus and plus you have to give very carefully. Very carefully. Otherwise, for example, if you give this is a plus and minus means total complete drawings. Right? Clear? So, right? Now you understand this one. Now you understand this depletion mode. Number 8, regular 8, number 63. Now you understand or not? Again, I will repeat. Number 8. Okay. Okay. Next, we will go for the enhancement. Here, depletion. What is the meaning of the depletion mode? Here, it depleted the electrons. It depleted the electrons. Here, one person written that source. One person he said that source near the source, right? So here the source, this is the source, right? Source is here. This is a negative, right? This is a negative, right? And this is a positive, right? Here positive and negative almost all it attract. So here the negative charge will becomes less. Here this is positive, it is connected, and this is a negative, right? Right, the both are attracted, and then thereby also the electrons of free charge will be reduces. This electrons reduces. Thereby here the totally the electrons will be depleted. So that's why we can call depletion mode. That means depletion mode means the current decreases. The current decreases. Here the positive charge dominate. That means here the positive charge are the majority carriers. That is holes are the majority carriers. Number 8, if you give positive to G and negative to S, then what happened? Yes, Mr. 80, next we are discussing that only, that mode only. So Nagaraju, you are right. What you said, if you give positive to G and negative to S, then it becomes so the we can increase the current. Here, this is depletion mode. We can decrease the current. We can regulate the current. That means this depletion mode we can use to decrease the current. Whereas what you said that if you give positive to G and negative to S, then what happens, or you asked that question, that is enhancement mode. That is, you can increase the current. You can increase the current. Next, we'll discuss next one. Next is there. A good question. Right. Now we'll go for the next. This is enhancement mode. So now if you see clearly, correct. If you see now, if you see here, this is enhancement mode, right? In the enhancement mode here, the gate you are connecting positive, and here the positive terminal. When you increase this gate to source voltage, this is one plate, and this is another plate. This is two plates. In between these two plates, dielectric is there. That is insulator silicon dioxide. Here the positive, this is one side of the plate is positive. The other side of the plate automatically the negative charge develops. The negative charge, this is the electrons. Electrons it develops. And this side is the N type, right? So here also negative charge develops. More negative charges. And here also this side is also, see here, the negative is connected to N. This is N type semiconductor here. So both will repel. Thereby yet here only the negative charges. They will remain the same as it is. So that means the negative charge, that means the electrons are more in this case. Once the electrons are more means here, these electrons are depleted, this P type. Here the P type substrate is there. That is a positive. So that means that the electrons will dominate here compared to the P. That is a positive type. So the drain current, what happened here? The drain current increases. The drain current increases. So now it is clear, Nagaraj. This is enhancement mode. Again, I'm repeating, all of you listen carefully. Here now in this, the positive is connected to the gate. This is a plate, right? And this is another plate. In between these two plates, silicon dioxide is there. When the negative, that is a positive gate to source voltage, increases, one side is positive, the other side is a negative charge. That means the negative charge developed here, the other side of the N channel, right? That is, this is the N channel, right? Here this is N and this is N. That means a negative charge here develops. Negative charge is more. That is dominating this P type. That is a positive charge. So here the drain current increases. With the help of, by increasing the positive gate to source voltage, there will be a increase in the current. Whereas in the case of the depletion mode, when you increase the negative to gate source voltage, what happened? The drain current decreases. Whereas in the enhancement mode, the current increases. Whereas in the depletion mode, current decreases. That means we can regulate this. We can regulate the current with the help of this MOSFET. So according to our output, we have to go for depletion mode or enhancement mode. Two modes. We can vary two modes. We can give VGS as a negative voltage, then automatically depletion, the current automatically decreases the output. Whereas in the case of the enhancement mode, when the VGS is positive, if you increase the positive voltage, thereby automatically the current increases. So here that means negative charge developing is more. So any questions? So now it is clear. So okay, right. Just 5 minutes we'll go complete, then we'll go for attendance. Then next. So this is the drain characteristics. If you see the drain characteristics, see here, this is VGS is in off. This line is VGS is in off condition. That means no work. At that time, the drain current is 0. At this time, the drain current is 0. That means it is in off condition. I will tell you. That means it is in off condition. So that means here the VGFs, if you see clearly, this VGS that is in off condition. See, that means no supply of negative charge, right? So automatically the current is at 0, the drain current. Seems so what we discussed there. See here, when VGS is in VGS, see here VGS, this you see here clearly, if VGS is in this line, actually x-axis is a drain to source voltage. In this y-axis is a drain current, and this is a VGS. And then a VGS is in off condition means here the drain current is 0 at here. And then if you see VGS is equal to 0, that means if it is a negative gate to source voltage, then it is called depletion mode. And a positive gate to source voltage is nothing but enhancement mode. Means here the drain current, the positive voltage of gate to source voltage applies, the drain current increases. You see in the graph clear. It's a very, very important expected question in JNTU Kakinada, MOSFET compulsory question. So you better put star. And then if you go for the next one, transfer characteristics. In the transfer characteristics, the same similar. See here, this is x-axis gate to source voltage, and this is a drain current, and this is a VGS, right? See here, this is negative gate to source voltage. From 0 to, this is a negative gate to source voltage. That is called depletion mode. When you increase the negative gate to source voltage, it is in depletion mode. That means a drain current falls to up to off condition. That is a VGS in off condition. When the gate to source voltage is positive, then from this point it acts enhancement. That means the drain current increases. The current increases. Whereas in the depletion mode, the current falls. Whereas in the enhancement mode, the current increases. So any questions? Any questions? Any questions? So it is clear, Nagaraju. Number 380. Number Suresh Paul. Suresh Paul, you asked that. Suresh Paul. Suresh Paul. Okay, no, you understand Suresh Paul? You asked the question, right? Suresh Paul. Okay. Okay, anything else? So it's very, very important to note down. So maybe next class, again, I will repeat it for 15 minutes. Why? Because it's very important. Those who are not attended today, next coming class also, I will repeat for 15 minutes because it's very, very important. Put star mark compulsory question in 2 sets. Compulsory question in 2 sets. 2 sets compulsory question with star mark. Better put star mark. So if you go for the previous question paper, this MOSFET asked, sometimes they asked in 3 sets also. MOSFET, field effect transistor, metal oxide semiconductor. You have to draw a MOSFET construction for 16 marks. They are asking directly for 16 marks. You have to draw the MOSFET construction symbol, and next we have to go for 2 modes, depression mode, enhancement mode, and then you can write down the drain characteristics and transfer characteristics. All these things, if it is there in the paper, you can get out of 16, you can get 15 or 14. So because it is a theory, they will not give the complete marks. Correct? So important question. Again, I'm repeating, you have to put star marker. This MOSFET very important. Now, you have to respond attendance one by one. Number 1, right, 4, 5, 7, 8, okay, 4 present, 7 absent, right, 9, 9, 10, 11, 13, 14, 13 absent, right, 15, 16, 17, 18, 17, 19, 20, 21, 22, 23, right, 24, 25, 26, right, 27, right, 28 present, right, 29 present, 30, 30. 30. Right. Option 31, 32, 33, 34, 35, 36, 37, 38, 39, 41, 42, 42, 43, 44, 45, 46, 48, 48, 48 option, 49 present, 50, 52, 54, 55, 55, 55, 60 present, 56 option, right, 56 present, right, 60, 61, 61 present, okay, right, 63, 64, 65, 66, 66, 67, 68, 67, 68, 68 present, 69, 70, 71, 73, 73, 74, 75, 76, 77, 78, uh, 78, okay, 79 present, right, 80, 81, right, present, 83, 84 present, 85, 85, 86, 88, 89, 89, right, 89 option, 90 present, 91, right, 92, 92, right, lateral entry 1, 2, 3, 4, 4 present, 5, 6, 6, 6, 8, 9, 10, 10, 11, 12, 13, 14, all right, 14 present, 15, 15, present, 16, 17, 16, 17, 18, 19, 20, 21, 23, 23, 24, 25, 26, 26, 27, 28, 29, 30, 30, 31, 32, 32, 33, right, 34, 35, 36, okay, 36, 37, 38, 39, 40, 40, 41, 43, right, and just I will read the option is, all of you see here, right, then number 7, 13, 17, 22, 30, 48, 50, 55, 67, 69, 73, 22 presenter. So here again I'm reading the option is 7, 13, 17, 30, 48, 50, 55, 67, 69, 73, 85, lateral entry 3, 10, 12, 13, 16, 17, 23, 23, 26, 26 present, no? 30, 30, 30, lateral entry 30, 32, 35, 40. So these are the opportunities. 76 present already, and 18 by 326 is also present. Okay. So again, I'm repeating regular 7, 13, 17, 30, 48, 50, 55, 67, 60, 67, 69, 73, 85, lateral into 3, 10, 12, 13, 16, 17, 23, 30, 32, 35, 40. Lateral into 30, okay. 35 permission. Yes, sir. Okay. Okay, we'll end the class.